Good evening, everyone. My name is Martin, and I'm talking today about intelligent household waste collection. In particular, I will describe a solution that motivates people to generate less garbage, and this solution uses research methods from statistics, economy, and computational social choice. I have divided my talk into the following 5 parts. I will start with a brief motivation about the problem. Then I will identify and formulate some related goals. After that, I will describe a new approach and also talk about 2 self-evident concepts in the context of household garbage collection. These concepts are efficiency and fairness. And lastly, I will give some related references. Let me start with the motivation. In 2015, the United Nations proposed the 2030 Agenda for Sustainable Development here in Europe. Their plan includes 17 main targets, and one of these targets is related to climate change mitigation that aims to reduce air pollution in general. Part of this pollution is caused by household garbage. In fact, in 2013 in Berlin, household garbage constituted around 80% of all municipal garbage. This includes commercial, bulky, and street garbage as well, beside the household garbage. In response, the European Commission has developed a number of programs based on the concept of circular economy. Unfortunately, such economies do not motivate households to generate less garbage. Yes, that's true, even though it may seem surprising to some of you, but circular economies, they motivate households to use recyclables. In fact, household garbage generation behavior relates to factors such as lack of awareness as well as the adoption of inadequate policy. Thus, one can argue that household garbage avoidance relates to the minimization of garbage generated due to these factors. In this presentation, and also in my work, my research work, I look at this problem, the problem of household garbage avoidance. To clarify this, let me provide an additional context. Circular economies are indeed a wonderful tool that motivates people to use recyclables. However, as I just mentioned, there is a big problem with them. They do not motivate people living in households to avoid generating garbage. I will show this in the next example. Let us consider the person on the left and assume that in 2020 they produced 50% less garbage than in 2019. Despite this fact, they paid the same amount in 2020 for the same services as in 2019. This is because the garbage trucks here in Berlin and in many other European cities run on fixed schedules. However, this also suggests that the dispatching of such trucks is not efficient, or at least is not as efficient as we would like it to be. Next, let us look at the person on the right and assume that in 2019 they produced 50% less garbage than their neighbor on the left. Yet, they paid the same amount for garbage collection services. This, on the other hand, suggests that the allocation of costs is not fair. In conclusion, both of these people in this toy example are not motivated to avoid generating garbage simply because they do not save any cost by doing so. These simple observations motivated me to formulate the following 3 objectives, namely, How can we dynamically schedule garbage collections? How can we efficiently assign such collections to garbage trucks? And how can we distribute fairly the associated costs to households? My response to these goals is to propose an Internet of Things solution which uses sensors to detect the fuel level of garbage in containers from household collection points. The solution then sends this data to a central server that schedules collections and provides regular feedback to garbage collection companies and households. The companies, on the one hand, can use this data to schedule garbage trucks more efficiently and allocate garbage costs more fairly. The households, on the other hand, can use this data to reflect on their garbage generating behavior and hopefully reduce their levels of generated garbage in the future. And also by doing so, saving costs. Next, I'm giving more details about efficiency and fairness in this context. I do this again by means of a simple example. Let us consider a street where 6 households live and assume that the trucks collect their garbage once a week. However, in the current week, let us suppose that the 2 most left containers are less than 50% full prior to the garbage collection. This means that the company could save operating costs by visiting these containers in one of the following weeks and not in the current week. Indeed, this would be more efficient for them. Thus, the weekly cost C of collecting the garbage should only be covered by the households whose containers are almost full and emptied in the current week. This cost can be fairly allocated to households using the following simple formula, namely, the cost of a given household is proportional to their level of generated waste. Of course, in the real world, the problem is much more complex because there are millions of households in Berlin. Nevertheless, I could prove some theoretical guarantees for problems of any size. These are results 1 to 4 on the slide. I included some of these results in the paper. For example, let us look at the second result. By using sensor data, I proved that we can minimize the number of trucks subject to maximizing the number of garbage collections to be performed on the next day. This objective implicitly reduces the number of truck visits to sorting and incineration plants, which I believe may result in reductions of their associated carbon dioxide emissions in practice. As another example, let us look at the third result on the slide. In this result, I proved that fair cost allocations always exist and that such allocations are monotonic. Basically, this means that households that generate less garbage are guaranteed to pay lower costs. For this reason, I strongly believe that using such allocations, such cost allocations, could actually motivate people in practice to generate less garbage. Finally, I arrived to the end of the presentations, where I give you some related works on the problem. These works inspired me and also helped me to identify the need for new solutions to the problem of intelligent household garbage collection. And that's all from me, folks.